Lesson 11 of the school year. We're going to look at exponential functions for a second day. I know last time we were here, it's been a little while since we've taken a test, we've done some other things, but we're following up on what y'all did the last lesson, which was exponentials. Today, our goal is that we're going to learn how to do exponentials, but this time we're going to start with making sure we can graph them using technology and so on. So today, we're looking at exponentials. What an exponential is, if you want to write this on your packet right here, is anything where the power x is your exponent. That's what it means to be exponential, is that the x is going to be located as an exponent in the equation. Okay, so that's what we're doing today. With that, I'm going to get started here. To review what graphs look like, this is called linear. Now, ignore this green arrow here and the red arrow here. What do you notice about the blue? The shape of this blue and the shape of this blue. What do you notice about both of them? Come on now. What do y'all notice? What do you notice about the blue in this graph and the blue in this graph? Their shape. What type of shape would you describe those as? Does this blue look like a circle? Does it look like a U? What does it look like? A straight line. Yes, linear functions means our graph's going to be a straight line. The thing I want you to write down here is that they're going to give us a slope and a y-intercept. This right here is the slope, which remember that means rise over run. If you go, we write this down here. The 3 refers to the y-intercept. That would be your y-intercept. For that reason, they call this a slope-intercept form because it's giving you the slope, which is the rise over the run, and the y-intercept. Notice, where does this graph hit the y-axis? Everybody call it out. What value does it hit on the y-axis here? Let me go ahead and add an x here and a y there. Where does this hit the y-axis? Not -3, try again. +3 right there. That +3, that's what the 3 in the equation represents. Whereas the 2 is the slope. Notice this graph goes up 2 units with a run of 1. You might remember when we talked about linear, if it doesn't show you a run, the run is automatically 1. If it doesn't show you a run, the run is 1. So this goes up 2 units over 1. Up 2 over 1. That's how you would draw that graph. Okay, so that's linear. It has what we call a degree of 1. That means the power on x, the highest power is 1. If the highest power is 1, they don't even show you it. So said another way, a linear, you will not see powers on the x-axis. You will not see a power. Okay? Quadratic was the second equation we looked at. This is the next slide. Quadratic means you have a degree of 2. Said another way, you will have an x squared in the equation. This equation right here, if you want to write it down, would be y equals, let me see here, let me think. This would be parentheses x minus 1 squared minus 4. That would be the equation this time. That's a 4. That 4 showed, I got, whoops. Sorry, I'm trying to select the whole equation here. That 4 got put right on that line. There we go. That'll make it easier to see. That would be the equation here. Notice this equation, does it have a power? Yes. What's the power? 2. If you have a power of 2, your graph is going to bend like this. It's called a parabola. It's going to look like a parabola, okay? And there was key features there. You can look over that. There's just a review. Well, last class, we introduced a new function for you. I said it deals with money. If you ever want to buy a house, buy a car, get a loan, anything like that, it works off of these. They were called exponentials. So the next slide shows us an exponential function. This is exponential. Now notice, it has a curve to it, but it's not a parabola. It doesn't look like a U, but it does have a parabola. You might recall that it has a horizontal asymptote. This is a value that we talked about the graph will approach, but it will not go beyond that horizontal asymptote. This graph, it's like it's getting held up by this horizontal asymptote. So it curves to be held up by the asymptote, but it does not just break through it and go down forever like a line would. A line would just break through and keep going. And remember, a parabola on the previous page would make it look like a U. This one does not. What it does is it curves and it follows that asymptote. So that's what we're dealing with. Again, on this equation here, I have the equation, the last value. This is the y-intercept. Go ahead and put that on there. This is the y-intercept. This is the y-intercept. And the value that has the power, we call that the base. Now, those are just some big words. What that means is every value, it's getting multiplied by 2. The y value from the asymptote. The distance from the asymptote gets multiplied by 2. That's what this is saying. So what do I mean? When I'm at -1, this point, that's 1 unit away. Actually, these are counting by 2s. Let me go to a different spot. This isn't the right equation. That doesn't have a, oh, that's not the y-intercept. Take that away. That's the horizontal asymptote. Sorry. I'm losing my mind. This is the horizontal asymptote. And I have a typo here because my horizontal asymptote, I don't think when I wrote this equation, I don't think I realized this is counting by 2s. That's actually a -1, not -2. This needs to be a 1 right there. So our horizontal asymptote here is at -1, not -2. That's supposed to be a 1. Let me cover it up and write it cleaner. How about that? Sorry. Typo, got to fix it. Okay, here we go. -1. That's what the equation is supposed to be. Either way, that's what we're going to be looking at. That's what the graphs are going to look like, and that's what we're going to be seeing today. So you might be thinking, well, we had this slide already. I remember it. Well, what we're doing today, oh, I forgot to add this one thing. Would we call this increasing or decreasing? This function right here. What do you think? Increasing or decreasing? Valentine, what would you say? This first one. That is increasing. Go ahead and write that this is increasing on here. This is increasing, which means this second one over on this side is decreasing. If it goes down from left to right, it's decreasing. If it goes up from left to right, it's increasing. As the year goes on, we'll start to call this growth. If the graph increases to positive infinity, we'll call it growth. If it falls towards your asymptote, we'll call it decay. Okay, so that's the words that are coming, but today we're just going to focus on increasing or decreasing. Okay, now that I've hit all the review of our functions, let's start with looking what this lesson's all about. Okay, today we're going to be using our technology. So what I want you to do, this right here is like an exemplar to show you what we're doing. I'm going to give you an equation. We're going to type it into Desmos, and then we're going to go through all this process listed here. So let's first do this. Go to your Desmos, and I want you to type in this function. F of x equals parentheses 1/3, close your parentheses, to the power of x. That's what we're going to do right now. So let's go over to our technology. Okay, so pull up your Desmos. Type in f of x equals, I'm going to make mine a little bigger here. Do a parentheses. If you don't know how to do 1/3, it's 1, then the slash that's with the question mark. You don't have to press shift. 1/3, and then do to the power of x. To the power of x like that. Okay, giving you a moment there. So the first step we've just done, if you've graphed it in, the second step, it says click on the gear, and I want you to hit table. So this gear right there. Click on that gear, and I want you to hit table. Create table right there. Okay, so now that I've done that, I'm going to go to my next slide here. So after we've created the table, we now go on to Step 3. We have the table of values, and it'll also put points on our graph, okay? So that's what we need today for a lot of our information. That's the process that we're going to go through with technology. Okay, so it says using technology, let's graph this exponential function and determine the key features. So now that we've graphed it, let's go ahead and plot the points that we just found. So the points that y'all found were, where's the first point that you see on the table? Is it -2, 9? Go left 2, up 9. Left 2, up 9. Left 2, up 9, and put a dot on your packet. There you go, right there. Left 2, up 9, place that point. The next point we had was -1, 2. I should be going over here. Let's come over here. The second point is -1, 3. I'm sorry, -1, 3. That's the next spot we're putting on. -1, 3. Let's place that on our graph. -1, 3. So this is straight off your table. The next one was 0, 1. Okay, followed by 1, comma, 0.3333, and then 2.11111. We'll just have to guess on those. So 1.3333, and then 2.1111, something like that. Now, let's go ahead and draw the graph. We know what the graph is supposed to look like, but we put those dots on there. So let's draw this graph. Connect your dots. And it got really flat in here. Okay? So after we draw our graph like that, after we draw it out, the first question it asks us to determine, is the graph increasing or decreasing? What do y'all think? Is this increasing or decreasing? Sorry, I'm trying to find the best spot here. I like that one. It's decreasing. It is decreasing. I agree with you. Let's put decreasing here. This graph is decreasing. That's because it's going down from left to right. The y-intercept, or the initial amount. Where do you see the y? Where do we cross the y-axis? Where does my red curve cross the black y-axis? 0, 1. Very good. When you talk about y-intercept, you list it as a point, which is 0, 1. So if you had to answer the y-intercept as a point, you would say 0, 1, just like that. If you were talking about initial value, that would be when it's a real world problem. And so if it said initial amount, that you would just do the 1. Okay, that would be a real world problem. Okay, horizontal asymptote. Now remember an asymptote. That's where I described it as when I married my wife Abby. We started far apart. She was born in Michigan. I was born in Texas. But the whole idea is when we get married, the idea is that you follow along one another through life. You get really close, almost like you're holding hands through life. You're that close. We need to add the asymptote. Tell me, where do you think I should add this asymptote? So I'm just going to add it randomly on the graph. And tell me if you think it looks like the right location or the wrong location. If I put it on right there, is that the right spot or the wrong spot? What do you think? Should that asymptote be right there? Does that look like they're following hand in hand with each other? No, that would be like you cross paths with a stranger. Maybe this is you and this is me. In this stage of life, we have Algebra 1 together. But ultimately, we're not going hand in hand through life. Okay, asymptote is like me and my wife, Abby. So would this be where we need to be? Once again, this is just crossing at one stage of life. Would this be right where I need to be? No, I'm getting closer. Now, just let me give you one more incorrect one. Would it be down here? No, we're still not holding hands. Would it be like right there? Yes. You see how we're not the exact same graph. We're not exactly the same, but we are extremely close together. That's the right location. Now, when you write the asymptote, here's where people mess up, is they don't know what to do with it. It's always when you draw a straight line, it's always whichever axis you cut through at one spot. When I cut through, I'm cutting through the y-axis. This graph that I just drew cuts through the y-axis. So if y equals, now look on your y-axis. Where on the y-axis am I cutting through? It's blank. It's between 1 and -1. What number is between 1 and -1? Come on, speak up. What number is between 1 and -1? 0. So this would be y equals 0. That's the horizontal asymptote. Now tell me about domain. To know domain and range, we have a saying. What's our saying? Dr. XY. Okay, so I'm going to write that over here. We're looking at Dr. XY. Your graph, is it continuous or discrete? I didn't ask that earlier. Is this continuous or discrete? It's continuous. Now, if the graph is continuous, if this graph is continuous, do I use those squiggly brackets for domain, or do I use the symbols, the less than symbols? Which one do you use if it's continuous? Less than, okay. Do it for both domain and range. Put those symbols in. The difference is that domain is X from Dr. XY and range is Y. So fill those variables in. Okay, so now when we look at our graph, the x-axis, as I see, goes left and right. What symbol do you see farthest to the left? Do you see a dot or an arrow? We see an arrow. What does an arrow mean? Infinity. Now on the left side, when you look on the left side, are we dealing with the positive numbers or the negative numbers? Negative. So it's going to be a negative infinity for the domain to the left. What about to the right side? What's the farthest to the right symbol you see? A dot or an arrow? Arrow. What does arrow mean? Infinity. Now for range. Range is not x. Range is y. The y's are going up and down. You do the smaller numbers first. What's the lowest symbol you see? A dot or an arrow? Technically, it's an arrow, but this arrow does not go down to negative infinity. Why not? We said this is like a rule breaker last class. Why will that not go down forever? The answer is it's getting blocked. Why will this not go down forever? It's getting blocked. What's it getting blocked by? That horizontal asymptote. What number is that horizontal asymptote on? 0. This goes down to 0 and then it gets blocked. So even though it has an arrow, it gets blocked and it does not go further than 0. Different question. How high, or what's the highest symbol you see? Is it a dot or an arrow? Arrow. What does an arrow mean? Infinity. Since we're not getting blocked up, it does go all the way up to infinity. You might see these written as words as a reminder. When they're both infinities, it would just say the domain is all real numbers. All real numbers is how they would write that. But in the case of the range, since I have a 0, they would say the range is all real numbers. Is y, you talk about the y represents range. Is the y greater than or less than 0? Look at the symbol. Is y on the greater side or the less than side of the 0? Greater. All real numbers greater than 0. That's how you would write the range in words. Okay, so that's our example 1. Let's reload and let's try this again for example 2. Example 2. Oh, sorry. I have everything listed out just in case you got lost. There's all these values for you, but we've already done the problem. So let's go to example 2 now. Let's go graph this. Our equation is now changed. We're going to graph f of x equals 4x plus 1 and determine the key features. So let's go graph this. So I'm going to hit the refresh button here just to start over. F of x equals 4 to the power of, how do I do a power? Shift 6, looks like an arrow up. 4 to the power of x plus 1. Okay, I'm going to give you a second to graph that. All right, now that I've given you all some time, if you're watching the video, just pause it if you need more time. Now that we have a graph, let's go through the process. Do you remember what we did? That was step 1. We typed it in. Do you remember what we did step 2 to help us find our points? Yeah, what do we press to get our points? The setting, the gear, and then hit create a table. So these are our values. It looks like -2 is at just a bit bigger than 1. So let's go plot that. At -2, you're just a bit higher than 1. And then we go to the next one. -1, we're 1.25. -1, we're at 1.25. Come on, Ivan. We're getting the graph. And then at 0, it said 2. So put that plot on there, that point. We're going to just put the standard 5 points they give us. And then 1, 5, and 2, 17. Oh, I can't do that one. But 1, 5, I can do. 1, 5. And then 2, 17 would be way up here somewhere. I'll just kind of draw a dot up there at the top of my screen. Now try to connect your dots the best you can. Notice this graph does get flat. Exponentials always will get flat. What value is it getting flat on? You see how it's getting flat? This is where the graph's going to get married to a y value. What y value is it getting flat married with? Remember how I described an asymptote? What y value is that getting married to? Look at it right here. Where's it hitting? Where would that hit the y-axis? 1. Yeah, you could type that in if you wanted to check. If you typed in y equals 1, I'm going to change it just so it looks like a dashed line so you can see the difference in the two. You'll see that graph, you see how they're like getting married together? They look super similar. That's the horizontal asymptote. It's going to be a 1. Okay, so let's go connect our dots, and then we'll answer the questions. So this graph is going to, where did my pen go? I lost my pen. There it is. This graph is going to come from here. And it's going to hit these dots, and it'll come up way up here somewhere. I'm just going to draw an arrow and an arrow there, and I'll add in that asymptote. We already found the asymptote. We said that asymptote is at 1 right there. Okay, so let's fill out our information now. As we look at this graph, what would you say? Is this graph increasing or decreasing? Increasing. Let's say it is increasing because it's going up from left to right. What is our y-intercept? Where do we cross the y-axis? Not 1 this time. 2. Now, if you just say the number 2, you're talking about an initial amount. If you were asked for the y-intercept, you have to do it as a point. What's the x value when y is 2? 0. And you can look on the table and see that. On the table, it says it's 0, 2. Right there, it says 0, 2. That's right. Okay. Now, horizontal asymptote. We found this. This asymptote right here. Which axis does it cut through? That's how you always list the variable. Does this cut through the x-axis or the y-axis? The y. So it's a y equals. And you're right. Y equals 1. Good job. Y equals 1. Now, for domain and range, the question is this graph continuous or discrete? Are we dealing with a connected graph or a dotted graph? Is this continuous or discrete, the graph? I see dots, but I also see a line going through the dots. What would you call this? Continuous. This is connected. Even though there's some dots shown, that still makes it continuous because those dots are all connected together. When the graph is continuous, let me do Dr. XY over here. If your graph is continuous, do I do the squiggly brackets or do I do the less than symbols? Squiggly brackets are for discrete. When it's connected, you do the less than symbols. So let's add these in. We're going to, for domain, we'll have these symbols with an X. For range, we'll have these symbols for a Y. Okay, help me out here. How far domain is X? Look at the X-axis. Which way does X-axis go? What 2 directions? Left and right. What do you see farthest to the left? Do you see a dot or do you see an arrow? Arrow. What does it mean if it's an arrow? Infinity. Now, oh, good catch, Deja. We're on the negative side, so it's a negative infinity. Okay, now, what about when you go to the right? What's the symbol you see farthest to the right? An arrow. And what does that arrow mean? Continuous. Even though I have a dot up here, this arrow is going to keep going. No, it doesn't mean continuous. Sorry. What does the arrow mean? Infinity. That's what it means. Infinity. Okay, let's talk about range. What's different when we do range? It's the only thing different than how we do domain. You're looking up and down. So look at the smaller numbers first, which would be the bottom end. What's the lowest symbol you see? A dot or an arrow? Arrow. Arrow usually means negative infinity. Exponentials are the rule breakers. Why does this arrow Over here on the left, why does it not mean negative infinity this time? What happens to it? It gets blocked. What y value is blocking this arrow from going down? 1. So put 1 there. We get blocked at 1. Now, we're not going to say the 1 with the line underneath because you're not actually equal to the 1. That's just barely below it blocking it. It's not equal. They're not the same graph. They're two different graphs. That horizontal asymptote is not equal to the curves. Because of that, you don't put the equals line. You just leave it like that. Now, how high? What's the highest symbol you see? Is it a dot or an arrow? Arrow. What does arrow mean? This and for the case of going up? Infinity. There's nothing blocking it up there. So the way you would write this or have it show up to you if you were taking a test is you would see this as being all real numbers. All real numbers. That's how they would write the domain here. But range would be, the range is all real numbers. The only question you need to ask yourself is y greater than 1 or is y less than 1? Look at the y value. Is the y on the bigger side or the smaller side of the symbol? Bigger. All real numbers greater than 1. That would be your answer for the range. All real numbers greater than 1. Okay, with that, I'm ready for you to start your first DOL. I want you to try this one. Okay, go ahead and try this question here. Now, if you finish that one, you can try the second question. Why is it not moving? Here's the second one. You can try that as well. DOL number 2. All right, now after giving you all time for DOL number 2, we're going to look at example 3 here. So example 3, we're going to finish with this. This problem, what I've done is I'm giving you a graph and we're going to come up with an equation. So I need everybody following along here. This is really important for you to figure this out. The first thing you're going to do is given a graph is you have to create a table yourself. What are we doing first? Creating a table ourselves. So at the top right of your screen, I pasted a little graph, or a little table to write in values. So let's find 3 values. You'll only need to have 3 for algebra 1. That's all you'll ever need is 3 points. How many points do we need? 3. And I'll get you enough. So let's look at our graph and find 3 good points. What do I mean by that? I mean like points like this that perfectly go to an x and a y. What is the x value right there of that y-intercept? What's the x value? 0. What's the y value? Not 1. You can look on your packet if you need to. 3. 0, 3. So our first point that we're going to type in the calculator is going to be 0, 3. Okay, now look on there, try to find another good point on your graph. I see another one. I see one at -1 when x is -1. When x is -1, what's the y value? When x is -1, what's the y value? Perfect. -1, 6. That's going to be our second point where we're going to type in the calculator. There's one more. We need to find one more. You can do more than 3 if you want to, but you don't need to ever do more than 3 in my class for algebra 1. What's another point you see on the graph? How about when x is -2? When x is -2. What's that point right there when x is -2? I think I heard an answer. What'd you say? 12. Perfect. Those are going to be our 3 points. Now go back over to your delta math, and we're going to get an equation. I'm going to hit my refresh button just to make everything disappear. And so here's what you do. If you don't have an equation, you have to find one. You're going to choose a table first. Just finish this and I'll let you go. It only takes like a few seconds. Okay, we're going to create a table first. Do y'all remember how to create a table? Okay, now if you've refreshed everything, you hit this, table's not there. So how do you get a table? You can type in table or you can hit the plus and choose table. Get a table. Everybody get a table. Refresh it, get a table. I don't know what button to press. Okay, there you go. Get a table by hitting the plus. Now type in your points. We had 0, 0, 3. Our second point that we put was -1, 6. And our third point we had was -2, 12. Now, if you notice there's a little magnifying glass, that just means you have a point that's off your screen. If you hit the little magnifying glass, it'll show you all 3 points. Now, you don't have to do that, but you can do that. Now, go over here to where you have the dots with the line between them button. I want you to hit that one. When you do that, it's going to give you a linear regression. A linear regression means the calculator is going to come up an equation. Now, look at your points and look at the line. Does my line go between all the points? That means the graph is not linear. In our class, we're going to deal with 3 types. We're going to deal with linear, quadratic, or exponential. So is linear good or bad? What would you say? Linear is good, linear is bad here. Bad. Why is it bad? It's not going through the points. So we switch. The next option would be quadratic, which is right below it. Try quadratic. Now, does that look good? Quadratic does look good, but on this problem, I actually want the exponential because quadratic, look what it does on this side. Do you see how it makes the graph curve like this? Was our graph supposed to curve on the other side? No. So we're actually not going to choose the quadratic because it doesn't make the other side look good. So what's the other option? Exponential. And that's what this lesson was about. Choose exponential. When you choose exponential, let me press the home button here to get back. When you choose exponential, it gives you your equation right there. That's our equation. Is everybody getting the same equation? Y equals 3 times 0.5x to the power of x. Okay, let's go right in our equation. Our equation is, on this one, y equals 3 times 0.5 to the power of x. That was our equation. Whoops, the x didn't come through. There you go, x. Is this graph an increasing graph or decreasing graph? Decreasing. This graph was decreasing. It was going down. Very good. Which later we'll call a decay. What is our y-intercept? 0, 3. By the way, the y-intercept is the front value in the equation. That has a 3 there. That's why the y-intercept is a 3. Unless you have a, well, no, never mind. I'll be quiet. We'll just get it from the graph. If it said initial amount, you would not say 0, 3. If it was initial amount, the answer would just be
3.
3. That's correct. That's for real world. They do that in real world problems. Okay. Horizontal asymptote. That means where's the graph getting flat and married with? What value? So I'm going to do an incorrect answer first. What if I thought the answer was y equals 3? Let's just say I thought this was supposed to be y equals 3. I want you to go to your graph and type in y equals 3. What do you notice? So underneath this, I'm going to go to the new line where it says 2. And I'm going to type in y equals 3. Does the graph look like it's getting married to that line when I type in y equals 3? That means I made a mistake. What's wrong with y equals 3? Too high or too low? Too high. So I'm going to change it from a 3. Let's try a 2. Okay, so at 2, we had that announcement come up. Did we say it's too good or it's too still off? Off. What's wrong with 2? Too high. Do y'all know what number it needs to be? 0. So I'll type in 0 here. Let me try this again. I'll type in 0. Does that look right? Yes, it is. Okay, so I'm going to go ahead and add that to my graph just so I can look at it over here and stay over here. My asymptote needs to be at 0. So I'll add that in right there to the notes. And I want to change what I did wrong earlier. Earlier I said it was 3, and we said, no, that's wrong. The value should be 0. I'll correct that. Okay, so domain. On this picture, what do you see farthest to the left? This time I don't see a dot. I don't see an arrow, so we need to add something. On this graph, do you think the graph stops right there at the farthest to the left? Do you think it stops there, or do you think, since it's going off the screen, it needs to be an arrow? What do you think is best? Arrow. I'm going to add an arrow to our notes. Let's add an arrow into there. So how far, what does an arrow mean when you talk about going left and right? Yeah, it continues to where? Infinity. Oh, I didn't ask. Is this continuous or discrete graph? What does that mean about my answer? Squiggly brackets or the symbols? Symbols. So let's do this. This will be an X in the middle. And this one will be a Y in the middle. Okay, you just told me negative infinity for the left arrow. Okay, how far to the right does this graph go? How far to the right? Do you think the graph just stops there, or do you think it needs to have an arrow? Arrow. I'm going to add an arrow there. The farthest right symbol is an arrow, which means infinity. That is all real numbers. All real numbers right here. All real, whoops. Looks like I'm yelling at you. Caps. All real numbers. Okay, let's talk about the range. So usually we go bottom to top. What's the lowest symbol you see? Is it a dot or an arrow? Arrow. But this arrow does not go to negative infinity. Why does it get broken up? Or why is it not going to be negative infinity? No, so I have nothing to do with that. We're looking at the y-axis. Why does this not go down to negative infinity? Because this curve gets blocked. What does it get blocked at? Where? At 0. This graph gets blocked at 0, so it only goes as low as 0. How high will this graph go? What's the highest symbol you see? Arrow, which means infinity. Okay, this answer would be all real numbers greater than 0. So now you've seen how to get an equation from the graph. All real numbers or from Desmos. Greater than 0. That's how this would look in words. All real numbers greater than 0. And it's greater than because y is on the bigger side of 0. Okay? With that, you have your last DOL. Here, go ahead and try that. I included what you might have had to do on, this is what they had to do on STAR. They had to be able to graph this and then get the points and choose if it was linear, quadratic, or exponential. Again, this wouldn't be exponential because the x is in the exponent. That's why they call it exponential. But there's your DOL. Okay.